Yo, what is up, fellow math gamers? We're back to another problem-solving session on the TST 2020. Let's get this gamer-tastic night started. Well, first of all, Daniel chooses 6 distinct lattice points I, J, where I and J are between 1 and 3 inclusive. What's a lattice point, you ask? That's a fantastic question! As soon as I get the pen function working. So, lattice points are essentially dots on the coordinate grid that at full integer indices. Pretty straightforward, isn't it? I expected only as much. So for instance, the dot 1, 1 is a lattice point, and the dot 1, 2 is also a lattice point, and even 2, 1 is a lattice point. That's pretty amazing. So let's fill in the rest of the lattice points, shall we? Alright, close enough. We don't need no specifics here. We're all about winning. And when you win, you don't have to be this precise. Just make sure you get the right answer and we'll be on our way. What's the probability that, given that he chooses 6 points at random, like for instance, I don't know, maybe he picks this one, this one, this one, this one, this one, this one, something like that, then he can draw 2 straight lines that pass through all 6 points. Now, if I were Daniel, I'd be a little smarter and make my line a little thicker, you know? Like, what if I just, do something like, this. No, that's not a straight line. Unfortunate. You see, they have these fun, fancy little rules. Only lines can only be of width, negligible width. So you'll have to pass exactly through the points or it doesn't count. Taking that in mind, we note that the maximum number of points we can actually have a line cross is something like, you can have something like this. You can have something like this. You can even go diagonally. But no matter what, you can't pass the magic number of 3. See, as long as this line passes through here, you saw nothing. But no matter what, every line passes through at most 3 points. Therefore, we realize that no matter what 6 points we choose, if we draw line 1, it can only pass through 3. If we draw line 2, it can only pass through 3. And only if these points all do not share with one another can we get the target number of 6 points. Therefore, we've identified what we exactly need to find. There are so little possibilities, we can instead do the problem upside down because we're that rad. Instead of needing to test every possible combination, all we need to do is generate the number of combinations of 2 lines through 3 points, such that all 6 points are different. Well, let's begin, shall we? So, supposing we draw 1 vertical line, we note that we can no longer draw any horizontal lines that pass through 3 new points. In fact, the only way to draw a line through 3 new points is through drawing it through another vertical line. And the number of ways to draw 2 vertical lines that satisfy these conditions is going to be 3. You can have these 2, you can have these 2, you can even have these 2, but no matter what, you can only have 3 in total. Similarly, when you do horizontals, you note that you can have these 2, you can have these 2, you can have these 2. What if we try drawing something diagonal? If we draw this diagonal line, will there be a second line such that we can get another 3 points? It looks like the answer is no, with a resounding no. So it would appear that the only way we can draw 2 straight lines in this situation is if it's one of our 6 possibilities, as illustrated above. Now the question is, how many ways can Daniel actually pick all of these points? Well, that's a fantastic answer. Have you ever heard of combinatorics? Let's try it. So given 9 points, choose 6. Why, that's just 9 choose 6, which is equal to 9 factorial over 6 factorial times 3 factorial. And what is that? Well, we know that 9 factorial is 9, 8, 7, 6, 5, 4, 3, 2, 1, and 6 factorial is 6, 5, 4, 3, 2, 1. We can cut off all that 6 to 1 nonsense. All we're left with is 7 times 8 times 9 over 1 times 2 times 3. Alright, this part multiplies out to 72, this part multiplies out to 6. Kill them all. We're left with the 12 times 7, that's 84 ways. So we've got 6 satisfactory solutions in the total pool of 84 possible. So 6 over 84 simplifies out to 1 over 14. And let's check the answers to see if we're on our way. And what would you know? The answer is 6 over 84 or 1 over 14. We got him, boys! Yeah, let's be proud of yourself. Alright, I'm going to send you on your way now. Hopefully you find the other problems just as entertaining. See ya! Ah, my throat.